We've now got a working template that creates a custom model and is able to run a successful analysis with custom loads, load patterns, load combos, and section cuts. Now it's time to learn how to get some of the results we've obtained in SAP 2000 and export them to Excel so we can manipulate them more easily. To get results from our SAP 2000 model, we have two ways of extracting them. One is the API functions that are designed explicitly for this. This is the method we'll be using. The other is going through the database tables, which we'll touch on, but we won't be using since it's harder and significantly slower to execute when compared to the functions provided by the API. Let's add a new macro to our SAP 2000 ULS module called Export Frame Results. It will only need our SAP 2000 model to work. So, what exactly will we be doing with this function? We'll do something a bit different and rely on interactions from SAP 2000 side for a change of pace. Our function will export the results from frames we have in our model, but only the ones that are selected. That's right. Remember that, while we've been manipulating SAP 2000 from our end, using only code and not relying on anything else, we can also depend on some interactions being made directly in SAP 2000 since sometimes that's just easier. Always keep in mind that, if it's advantageous, you can leave some operations to SAP 2000 since you don't need to be bound by your code. So, this function will create a new worksheet specifically for frame results to be exported to. Before we continue, let's add a couple of auxiliary functions to help us add worksheets with custom names. First, we'll create a procedure to add a worksheet with a custom name. We'll give it a name and the worksheet will be called by that name. Simple enough. The second function we'll code in the next video. For now, let's simply add the new worksheet by writing worksheets, add. Then, we'll write after sheets, sheets.count between parentheses to add our new worksheet to the end of our existing worksheets. Then, we'll immediately set the name of our created worksheet. Alright, now let's look at the SAP 2000 API documentation to see what function we'll need to call to get the results from our frames. Let's go to Functions, Analysis Results and Results. Here, we can find the most common function to get results directly from the API. The FrameForce function has a very long list of parameters. These are output parameters, which means that, while we don't need to worry about filling them, we do need to declare them all to get any useful information from the function. We obviously won't go over all of them because there's so many. Let's now declare all variables to cycle the selected objects, all the variables for the data fields themselves, and format the worksheet. Right, that was a lot of repetitive code and we're not even done yet. We'll also format the elements column with a date format separated by forward slashes. Why are we doing this? Well, SAP 2000 creates the internal element names separated by a hyphen and Excel can interpret that as a date. Okay, let's get the selected objects from SAP 2000. Set the current row to the second row so we can export the results, and let's add a for cycle to iterate through all our selected objects while checking to see if they are frames as we did before. Okay, so let's call our FrameForce results function with all the variables we created for it. We only need to take care to provide the object name and specify that it is indeed an object through an enumeration value for the second parameter. And now we can cycle the number results variable to get all the results relating to the element output stations for each of the load combos that we'll select for output. More on that in a bit. Anyway, let's then fill each row of the result output sheet with our FrameForce results. Okay, now let's add a new button and create a new macro procedure that exports all results to our workbook. We'll be fetching more results from the SAP 2000 API, but for now, let's restrict ourselves to the FrameForce's results. Let's call our function export results. We'll also declare the usual variables for dealing with SAP 2000 as well as variables for object selection and a model variable just to maintain readability. First, right after we get the active SAP 2000 instance, we'll get the selected objects and confirm that there are in fact objects selected. If no objects are selected, then we'll send an error message and we'll exit the procedure. Alright, now we'll deselect cases and combos for output just to clear any load cases or load combos that might be turned on by default by calling the deselect all cases and combos for output function. In their place, we'll call the set combo selected for output function and set our ULS G and ULS Q load combos for export. Then, we'll simply call our function to export the frame results. That should be it. Let's create a new model and run an analysis very quickly and see how it works. We didn't select anything, so we're getting an error message. Let's select a single frame object and see what we get. We can look at the new result sheet and see that it has exactly the same name as the frame we selected in the SAP 2000 interface. And it's separated by the object output stations. Let's select a large number of objects and let's export them to our workbook. Everything looks fine. Remember, if you want results on all the objects of a model, you can simply select all objects. Before we finish up, let's quickly touch on the database tables before we move on. The database tables are, essentially, SAP 2000's internal data structure and offer a very powerful and direct interaction with SAP 2000 but have little in the way of user protection. If you decide to use them, you should be prepared to know the tables you're dealing with. Getting results from the database tables is a lot easier than editing or adding data through them. You can find the database tables in their own dedicated tab in the SAP 2000 API. If you just want to get the information from a table, you can use something like the get table for display array or the show tables in Excel functions. If you wanted to edit the information of a table, you'd have to use the set table for editing array or other variants. These methods have some drawbacks. Namely, the tables, which have rows and columns, would be compressed into simple arrays, meaning you would have to handle them in a complicated way in which you simulate the lines by offsetting the index by the number of entries in each line. Additionally, SAP 2000 doesn't tell you which type of value is stored in each column. A value of 1 could either be an integer, a floating point number, or a string. And you'd have no way of discerning unless you know exactly what the table holds beforehand. After you're done making your edits, you'd have to put it in a waiting list and then commit its changes with the possibility of SAP 2000 rejecting your changes. Since you're making these changes at such a low level, the changes you commit might not propagate to other related tables like using the API functions does. If you delete a frame object through the database tables, its entry in the frame connectivity might remain and cause problems. None of this is meant to discourage you. It's still the most powerful and generic way of getting information from SAP 2000. Just keep in mind that it's a feature that should be used with caution and in-depth knowledge of the inner workings of SAP 2000. Okay, in the next video, we'll be exporting more results and learning how to handle errors in VBA.